2x minus 3.
I'm sorry?
I mean 2x plus 3. 2x minus 3, 2x plus 3.
That's a difference of squares. So then we have x equals 3, and x equals 3 halves, and x equals negative 3 halves.
So if the question were just asking us to factor, we'd stop and we wouldn't get that.
Yeah, but if it's an equation, it will not. Yes. If you are given an equation, it will not ask you just to factor the one side. Yeah. Good. Next question. Anything else? Is this better? Good. Awesome.
I was wondering, can we go over
Yes.
some of the inequalities,
Yes.
especially when they have like absolute value.
Yes. So number 8, the absolute value of 7x minus 7, divided by 7, greater equal to 9. Very good.
Can we try, like, can we try to do it?
Yes.
Like, I mean, is everything okay with it? Like, try to solve it first, like what she explained to me.
Yeah, so this was number 8 on the, yeah. And then after this, we go over number 7 as well.
Sure. I was hoping you did that at home so we can just check.
But, oh, this.
Yeah,
I mean,
I understand. Are we ready? Okay. So here's what I would do first. I would factor out 7, x minus 1, 7. Remember, you cannot touch the absolute value. You cannot take anything outside. You cannot put anything inside, nothing. So then I'll simplify, and I get the absolute value of x minus 1 greater equal to 9. Now remember, this is carved in stone. You can't solve it unless you change it. Don't cross it out like that. I'm just making a point. So if we don't know how to change this, how to convert this into what we can solve, then we're stuck. So how do I change this into what?
Wouldn't you put it into equation?
Inequalities, yes, yes.
So it's less than or equal to 9.
Careful.
Negative 9 is
And x minus 1,
greater than or equal to 9.
perfect. When I solve the first one, I have less than or equal to negative 8. When I solve the next one, I have greater equal to 10. This is that typical situation in which I have to put the union. It's the outside. It's the outside, not the inside. Greater than or equal to 9. To the left of negative 9, to the right of 9. So how do I write the final solution? I have to put this one first as negative infinity, negative 8. And I have to put the next one 10 to infinity because we read from left to right. So I have to write negative infinity to negative 8 union 10 to infinity. Now if you reverse these two, I will deduct points. No, but we have to write from left to right.
Okay, so if this original equation or inequality was the absolute value, what all that, but it was less than.
Then it would have been between negative 9 and 9.
Okay, so yeah, it would be the.
Much easier because I can put both together and solve at the same time.
Yeah.
So if it's less than, it's much easier. But if it's greater than, I have totally separate inequalities to solve. One less than negative 9 and the other one greater than 9. Is this clear? Better? Any questions?
And then number 7.
Yes.
And this, so this,
So let's look at number 7. In number 7, we have x minus 14 divided by 4 greater or equal to x minus 7 divided by 6 plus 1 over 12. Whenever we see fractions, we should not ever be afraid because we can eliminate them very easily in inequalities and equations. So I will have to eliminate. I shouldn't say I should. I would have to, but I recommend let's eliminate them. So what do? Yes. So we multiply everything by 12, but since they are fractions, I recommend multiply by 12 over 1 so you can simplify. Never distribute before you simplify. Simplify by 4, simplify by 6, and simplify by 12. So you distribute 3 to these two terms, 3x minus 42. You distribute 2 to these two terms, 2x minus 14, and then plus 1. And obviously this is more human than the previous one, right? So even looks better. I combine like terms first. 3x minus 42 greater or equal to 2x minus 13. And then I move 2x and I move 42. And I get that x is greater or equal to, I think, 29. And then I get x in the interval 29 with the bracket infinity. You don't have to graph, you just have to present the interval notation. That's good enough. Anything else that you would like to go back to? Anything?
we do one of the differential quotients.
Difference quotient? Yeah, there is not one in here.
I don't believe so, actually.
It's a very good point. So let's make up a function. Give me a quadratic function that you like. Any quadratic function.
X squared plus 7.
Let's say plus 3x plus 7. Good. So the difference quotient will be given to you. You don't have to memorize it. So it's f of x plus h minus f of x divided by h. So what we have and what we don't have and we have to work on? And the answer is we have f of x and we have h. There is nothing I can do to those two. So the only quantity that I have to work on is f of x plus h. So f of x plus h. What does this mean for the given function?
We have to substitute it in.
Yes, I'm ready and let's do it.
So the x of h squared plus 3 from the x plus 7.
Very good. Excellent. So now I have to square first. And remember we did this on the first day of classes.
So x squared plus 2x plus 3 squared.
Plus 3x plus 3h and plus 7. Let's stop for a moment and let me ask you if you have any questions on this. Is this okay? Everyone? Is this okay? Good. So now we have all pieces and I'm going to put them together and I will continue. So I replace all this. I replace f of x plus h by all this. So I continue here. So the top is x squared plus 2xh plus h squared plus 3x plus 3h and plus 7. Now I reach this point. So negative 1 has to be distributed to all three terms. So minus x squared minus 3x and minus 7 divided by h. So now I have to think for a moment and I remember that two things have to happen here. The first thing that has to happen is all terms without must go away. must simplify, not go away. You know what I mean. So x squared with a negative x squared, negative 3x with a positive 3x, negative 7 with a positive 7. The remaining terms have to have h in common. Why? Because the second thing has to happen. What is the second thing after those terms go away? What is the second thing that has to happen? The h in the denominator must go away now. So obviously the terms that are left, they all have to have h in common. So h is out, and that's how I get rid of it. But now the question is, I have 3 terms in there, so I have to present 3 terms in parentheses. Can anyone give us those 3 terms in parentheses?
2x plus h plus 3.
That's it, and that's the answer. 2x plus h plus 3, and this is it. Very good question, thank you. Anything else that you would like to go back to? Any problem? So we have about 25 minutes. Let's do as much as possible from this handout, whatever else you need.
Can you do the one with substitution?
Yes, let's do the one with substitution, of course. So we have x to the 4th minus 29x squared, 6, and plus 100 equals 0. So if I ask you what type of equation is this, you will first say it is polynomial. Because it is polynomial. What is the degree? How many solutions I have to write? Perfect. Okay, so now I really don't know how to factor this per se, 4th degree with 3 terms. So that's why the problem is asking me, well, use a substitution. So they're also saying to us, it is polynomial, but it's also what type of equation? In form, not quadratic. Quadratic will not have 4 solutions. So it's a polynomial degree 4, which means it's polynomial. It has 4 solutions, but it's also quadratic in form. So then I will say, give me any letter you prefer, doesn't matter. T it is, equals what?
X squared.
Of course, because this is clearly going to be exactly. Because if it's not t squared minus 29t plus 100 equals 0, then the equation is not quadratic in form. But it is quadratic in form because if I denote this by t, that is definitely t squared. So now you can do whatever you want. You have 4 methods. You cannot take the square root. It's not set up for that. You will not complete the square, I hope, because it's beyond the point. And you have 2 options. Either you factor, if it's quick, or quadratic formula. So which one is it? Okay. Okay, so let's factor then.
So t minus 4 and t minus 25.
Awesome. So we have 2 solutions for t. And those solutions are?
4 and 5.
But remember, nobody cares about t. T was our tool that enabled us to factor. So these are 2 other equations. What equation is this, actually?
X squared.
Very good. What equation is this?
X squared equals 5.
Of course, and this is typical. These equations are already set up exactly how I wanted them to be. And what do I do?
T squared minus
Exactly. Remember how many solutions I have to get. So that's why I wrote here degree 4 and 4 solutions so I don't forget. So then x equals?
2 and 2.
Very good. And x equals?
5. No, plus or minus 5.
Very good.
So we can write it like that and that'll be acceptable.
Oh, yes, of course. Of course, this is it. I don't need anything else. Good. Anything else, please look and say the next one is this, the next one is that.
Did we go over number 17?
17. Let's jump to 17. Okay, so we are given -5, -4, and we are given the point 510. I will only ask you to solve for y in the form y equals mx plus b. I don't care for anything else. So I find the slope 10 minus -4 over 5 minus -5. 14 divided by 10 simplified to 7/5. So one more time, y2 minus -4, which changes into +4, and 5 minus -5, which changes into +5. The top is 14 and the bottom is 10, simplified by 2, 7/5. So then we write y minus y1 equals the slope times x minus x1. Why? Why don't I use the easiest one, mx plus b? Because no point from what I was given is 0, comma a number. I'm not given the y-intercept. I should not try y equals mx plus b. It's a waste of time. It will. Can you determine it? Yes, but something like doing this instead of this, which is fine. I'll accept it, but I will not do that. So this is 7/5, and let's say I'm using the first point as -5, -4. So I don't know if you like this or not. This is kind of a lazy person's setup. But I prefer, instead of writing it one more time with parentheses, all sorts of parentheses and nested parentheses, I kind of prefer writing it underneath, and I see the negative, negative, and I see the negative, negative that will change into positive. It's okay if you write it again, but a lot of parentheses sometimes get confusing. So then y plus 4 equals 7/5 and x plus 5. I need to distribute 7/5 x plus 7 and minus 4. So one more time. 7/5 times x. 7 over 5 times 5 over 1 is 7, but then I have to move 4.
So that second, like,
So 7 over 5 times 5 over 1. Simplify first. Say it again, I'm sorry.
so that first part of the question is answered though. So you have the point slope form. and
Yeah,
that's
this will be the point slope form.
right, and then right underneath is what you simplify.
Yes, y equals 7/5 x plus 3. And this is final. This is the equation of the line passing through such and such. So the slope is 7/5 and the y-intercept is 0, comma 3. See, if you use this, you will still determine the y-intercept, even if you don't want to. It's okay if you decide and if you learn in high school to determine the y-intercept first, that's fine too.
Can we do 18?
Yes, let's do 18. Any questions on this before we look at 18? Are we okay, everyone? Okay, so let's take a look at, in 18 we have 7x minus 8, no, it's not 8, is it? It's 6, I'm sorry. I have the wrong glasses today. And I was too lazy to go back to my car. So we're asked to graph this line using x and y intercepts. So when x is 0, cover the term with x. You have to solve the equation, which is linear, -6y plus 42 equals 0. You have to move 42 to the other side. It becomes -42. -42 over -6 means y equals, that's it. So 0, comma 7 is the ordered pair representing the y-intercept. Now when y is 0, you cover that term because y is 0. And now you have to solve the equation 7x plus 42 equals 0.
-6.
Yes, because you move 42 to the other side, so then x equals -6. So -6, comma 0.
The part that confused me is that at the bottom on this question says if only one intercept exists, use it and another point to draw the line. It's just literally asking you to
Here's why. Because, let me graph it, and then I'll answer your question. Very good question. So when we graph it, we have 0, 7, 1, 2, 3, 4, 5, 6, 7. -6, 1, 2, 3, 4, 5, 6. Connect and extend the line and write 7x minus 6y plus 42 equals 0 so we don't forget what we graphed. To the left or to the right, underneath, above, whatever, somewhere. Okay, so now, see, if we have 3x equals y as an equation, the problem is that when x is 0, y is 0, 0, 0. With 1 point is not enough to graph. So then I have to make up another point. So I'm going to say, okay, x equals 1, y equals 3, 1 comma 3. So if a line passes to the origin, both x and y intercepts are at the origin, and that's not good enough. You only have 1 point. So that's why I had to fabricate, quote unquote, another one. But I selected x. I said 3 times 1 is y, and I determined y. I cannot just say, 5 comma 3. No, 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 no. I say x equals 5, and I determine the corresponding y, or vice versa.
Okay, so that was just kind of an aside. I was just saying.
Yes. So then when I graph this line, I will have to plot 0, 0, and 1, 2, 3. So this is the equation of the line. 3x equals y. Good. Next question. Anything else you would like to go back to? Anything?
Go over 16 one more time.
16?
Yes.
16, 16, 16. Oh, yes. Yes, the piecewise defined function. So we have f of x, which is 1/2 x squared for x less than 2, and 5x minus 4 for x greater or equal to 2. So what type of function is this? It's called, exactly, it's given in 2 pieces, so it must be a piecewise defined function. For any function that I have to graph, what is my first thought? First ever. I must find the domain. That's no matter what. So I look at this and I see negative infinity to 2. When you look at x less than 2, do you see negative infinity to 2? And then in that case, you see 2 to infinity with a bracket for the second one. Agreed? Now let's look at these and identify the domain for this. This is a domain for this piece. This is a domain for this piece, but I'm interested in a domain of the entire function. I will graph the entire function, not just one or the other of the pieces. Looking at this, can we add? Say it again.
So it should be an infinity. It's two domain, like it's 2 and infinity, right?
Do you all agree with negative infinity to infinity?
Yes.
So we have everything between negative infinity and 2. We have 2, and we have 2 to infinity. We have all real numbers for this function. Would you agree?
Yes.
Agreed? Charisse? So you're correct. This is the domain of this function. This is the domain of this function. But we're not talking about any of the pieces. We're talking about the entire function. So therefore, the entire function is defined everywhere. Is that okay? Better? So then, negative infinity to infinity f of x. I have to put in the table always 0. In this case, I also have to put 2. 2 is a key value for x. Why is 2 a key value for x? Because I have now this parenthesis and this bracket, and they're right under 2, and they are touching. Exactly in the same direction you see them in the domain. So this piece is 1/2 x squared, right? That's what it says. For x values between negative infinity and 2, we will be using 1/2 x squared. And on the other side, 5x minus 4. And you can say, well, why are you writing them again? Here's why. Sometimes these two will not be given in the correct order. So I don't want to plug into the wrong branch. So now I'm going to plug in -2. How much is -2 squared? And 4 1 times 1/2. Let's plug in 0. Perfect. Let's plug in 2. Very good. Right here inside the parenthesis. On the other side, let's plug in 2. What do we get? So 10 minus 46. And let's also look at 3. One more other point because it's linear. Good. That's all we need. From left to right, the first ordered pair, please. The next ordered pair, please. And the next one. What type of point is this? It's a parenthesis. That's why I put the symbol here. Very good. And we know how to graph this. We graphed it so many times last time. Good. We're done with the left branch. Now we're moving on to the right branch. Next ordered pair, please. Full point because of the bracket. The bracket says the point exists. And then 3, 11, so I'm going to graph it because I didn't plan ahead. I should have left more room at the top. So as you see, this continues forever, so the range will be from 0 to infinity. Any questions on the piecewise defined function? Any questions on the piecewise defined function?
Why is it 0 to infinity again?
From the lowest y value where the function exists. No, 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 yes, 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 yes. With horizontal lines. From the lowest y value till the largest y value. Anything else that you would like to go back to? Any problem that we haven't done, or anything else that we have on your mind? Anything?
I guess 8.
Which one?
Sometimes less, but
I couldn't hear. I'm sorry.
I guess number 3.
Number 3. Number 3. So we have a rectangular area. You can use length times width, or x, length and L and W, or X and Y. Doesn't matter. So the area of a rectangular wall of a barn is 48 square feet. What do I write? The area is 48 square feet. X times Y equals 48. The area for a rectangular shape is length times width. Then it says its length is 8 feet longer than the width. Its length is 8 feet longer than the width. The length is exactly y plus 8. The length is 8 feet longer than the width. What we have to do now is replace x in the first equation by y plus 8. It's the same thing. X or y plus 8, same thing. So y plus 8 times y equals 48. Remember, we refreshed our memory and learned new things on equations. We have 8 different types of equations that we know. What type is this one? Chances are, in my opinion, that if I manage to identify it correctly, I have huge chances of being able to solve it correctly. So what is it? Indeed. You could say, I don't know, give me a minute. And you will do this. And you'll say, yeah, it's quadratic. Because initially, from this you may say, oh, I'm not sure. You will distribute and now you'll know it's quadratic. Good. We have 4 methods. Will I complete the square? The answer is never. Will I take the square root? I can't. It's not set up for that. So I have 2 options again, either factor or quadratic formula. So what do I do? Okay. If it takes more than 30 seconds, don't waste your time. So y plus 12, y minus 4. So then indeed we have y equals negative 12 feet and y equals 4 feet. Which of these 2 you will not accept? Good. And once we have y equals 4, what will I say about x? Very good. I should go back and check both equations, and of course it works. 4 times 12 is indeed 48, and indeed 12 equals 4 plus 8. So this is the solution. Very good. Anything else? Anything else from anything?
I mean, if you wouldn't mind just running over those translations.
Oh, yes, of course. Yes.
I know we didn't.
Yes.
Do that last class, but
Yes.
for 2.5, there was like a couple. Like we could just go over like one of each type. Like if it's radical or if it's
Oh, so not this one from the end of the.
Oh yeah, no, exactly like that. So yeah, like I meant like you do one absolute value, one like radical, like just to go over them real quick.
Sure. Any particular transformations or?
Well, honestly, it was the ones that got kind of complicated. Like there was one, it was like g of x is equal to negative 4 parentheses x minus 3 squared plus 4.
X minus 3 squared plus 4?
Yeah.
Okay. Very good. So I just want you to be able to visualize this very quickly. It's x squared is the base function, correct? So we are moving it to your right. How many?
3.
Good. And then I have to stretch it because of that 4. Vertical stretching. And then I reflect because of the negative 1. And then what do I do?
Oh,
Correct. What is the vertex? The vertex has 2, x and y.
So negative or 3,
Comma.
4.
Exactly. Let's do it one more time. So it's x squared. To your right 3. Stretching. Reflection. Up 4. We haven't even graphed it. And we visualized the graph because we understood transformations. So let's do this one and then we'll do this one. Or since we started, let's do this one. Okay? So in order of transformations, number 1, first of all, I have to write x squared. That's the base function. In number 2, we have x minus 3 squared, which we know this is left 3. Then the next one will be that 4x minus 3. See, I'm not changing x now. Here I changed x, but now I'm not changing x. I have a 4 outside, which is a vertical stretching. Vertical stretching. Then number 4 is on number 3. Negative 4x minus 3 squared. What am I changing? I'm not changing x. I'm changing a positive into a negative for y values. Reflect with respect to the x-axis. And finally, number 5, which is negative 4x minus 3 squared plus 4, is not a change in x, but it's up 4 outside. So this is up 4.
Now, do we have any problems where we're reflecting over the y-axis or axis?
Any reflection over the y-axis will not be a function. Okay, it's a very good point. So yes, I'm sorry. I thought you were talking about a function reflecting it. So sorry about that. Let me answer and then I'll come back to that. Yes, the answer is yes. So we had the example of f of x equals the square root of x, and then we had f of x, let me call it g, not to be confused with f, equals the square root of negative x. Correct. So that was a reflection with respect to the y-axis. +4 changing to -4. -4 changing to +4. So this is a reflection with respect to the y-axis.
And then if you have that leaving sign on the
Outside,
of it,
exactly.
that's over
Yes,
that.
so we graphed this as the square root of x, and let me use a different color. And we graph this as the square root of -x. But if we want to find or graph negative the square root of x, then it will be this graph. We are reflecting it with respect to the x-axis. Not a good color. Yes. Anything else from this packet? Anything else that you would like to look back? Anything?